Hey everyone, welcome back to my channel where we intend to understand maths together. Today we carry on from the previous video, but first let's go over our last video's ground rules. Rule number 1. Repeated elements in a set are treated like single elements. Rule number 2. The order of elements listed in a set do not matter. Examples are demonstrated below each rule. Just for a better understanding of rule number 1, the reason why that's the case is because a set is a well-defined collection of objects and it doesn't matter whether something's repeated or not. At the end of the day, it's still well-defined. Alright, moving on. In the beginning of the video, I quoted that giving entities which are just things, symbols, is a more universal and efficient way of doing calculations. Well, what does that mean? Well, it means what is the least number of characters and symbols we need to express important pieces of information. It's basically asking, how do we write equations eloquently, which is to provide information without any delay or buffer. Now, giving things symbols may not seem important right now with simple equations and arguments. However, when equations and calculations become more complicated, like this one, well then it's more important to be able to stay on track, and symbols and shorthand help with that. A quick shout out to YouTube, try copywriting this image, that's my writing. Anyway, let's look further into shorthands. We use capital letters to represent sets. The orange circle you see is supposed to be a set, not zero. Apology for any inconvenience. The lowercase letters are used when talking about elements within a set. Again, examples are in the box. And a deeper demonstration is shown in white below. Capital A represents the set, lowercase a, b, and c are its elements. Now what you see below in yellow is a statement that says an element belongs to a set. That weird looking E that's between the letter and the number is just a symbol which means element of. Hence what the statement is saying is that 3 is an element of A, 2 is an element of A, and 1 is also an element of A. Alright, let's try some examples. Which bullet points below are true? The correct answers will appear in green and the wrong ones in red. Two and Z are both elements of A because they're both in the list above. The weird looking E with the line going through it is known as not element of. So the last one, it says 5 is not an element of A, which is not true. Hence it's red. I should have mentioned that earlier. Alright, I hope that made sense. Now let's look more into notations. If I define P of X as a set whose elements are defined by a specific property, then we can define a set another way as well. For example, imagine I wanted to make a set of all integers. You could write them down in a list, like normal, which would take ages, and maybe you would die before completing such a list, because it's infinite. Or you can draw a set with brackets, but instead of listing all of its elements down like normal, we just call all of its elements x. We put a straight line down after x, which means so that, and finally we describe what x is. So in the case of all integers, we draw the brackets, call all of its elements x, and describe x's properties, which is it's a set of all integers, as described below. The two symbols in the yellow box are called empty sets. They are sets with no elements. Every existing set can have an empty set, because none of the elements of the empty set are missing from any of the existing sets. Okay, let's try some examples. If Z is the set of all elements that are integers, N the set of all positive integers, and Q the set of all rational numbers, then Z has elements like 1, 2, 3 going to infinity, and the negative version as well. N has all the numbers that are positive integers, such as 1, 2, and 3. And Q has whole numbers defined as fractions. Also, a final separate example, we can define an empty set like this. Imagine we have x and it's a real number, but x squared is equal to minus 1. Then there is no actual elements that exist where x squared is equal to minus 1 because there's no real numbers you can multiply together, and its outcome would become minus 1. Now then, for the last part of the video, let's discuss a few definitions. A finite set is a set with specific number of elements which I'll call n. Now for an example, let's have a set with elements 1, 2. N in this case will be 2 because there's only 2 elements within that set. And for the set with elements 1, 5 and 3, N will be 3 because there's only 3 elements in that set. N is the size of the set. It's known as the set's cardinality. Remember, we use capital letters when talking about sets. So when we're talking about the cardinality of a set, we draw 2 straight lines and box that capital letter in between them. And that will be known as the set's cardinality. Okay, I hope you found that video insightful. I left a review here for you. Don't forget to subscribe and hit that like button.